Hello and welcome back to my series of videos about old calculator. Today I want to show you a very old one that I got recently, and I'm very excited about this one, but I have to explain one thing. I love calculators in a box because I think that boxes are very classy, and at some point, it was some kind of a luxury to have a calculator in a very nice box. So before we go to the one I want to show you, let's see a couple of examples like this one here. And this one is called a computator, so whatever you want to call that. And it's a very simple one where the whole idea is to push those sliders here. And when you do that, you move those wheels according to how much you push the sliders. And then you carry on every time you turn 10, you carry on one on the other wheel. So it's a very nice, compact, and very useful calculator that was very classy. It's in own box here, the computator. Next one is similar to this one. It's a little bit different in the way that this one is using chains. So instead of a small lever pushing directly on the wheels, you have some chain turning on the back here. But the same idea, you move the chain and then you can update those digits here, so you can add numbers, and you have a wheel here to zero the calculator. This one is Seidel and Newman, and they call that the Sun. Seidel and Newman, S-U-N. I think it's in German that the and was starting with a U. Anyway, very classy too. I love it. And the next one, I already did a video on this one. This one is called the Fuller calculator, and it's very simple and complicated at the same time. In fact, it's what they call a circular slide rule, and instead of being on the line, it's all around wrapping the calculator, which means that you can have a scale that is very long and very precise to make all your calculation. And there's a bunch of index here that will help you do your calculation. So you see, this one is already a nice box, a big one, and from the beginning of the century. But what I want to talk about today is this box, which is even bigger. It doesn't even fit on my camera. And this box, if you open the box, there you go, you get the Millionaire. And I'll present this one because I love it. It's one of the, I think it's the first one that was really commercialized, having a direct multiplication of the digits simply by one turn of the crank. There were a couple of other models before, and we're going to talk about that, but this one was the first that was really a commercial success. And they sold a bunch of these, and I'm really happy because I got this one. And the reason I'm happy is because it's the French version of it, so it's explained. Everything is explained here in French, and like it. But as you can see, the name here is in German. Maybe it's a hybrid model. Anyway, we're going to talk about how to use this one, and I want to talk also a little bit about the history of this one, because it's amazing. I did some research. It's really amazing. So let's make a brief presentation of the machine. On the left here, you have the number that will be multiplying or dividing or added to this number. And here on the bottom, you have the result. So let me zero that. Everything should be zero now. And zero this one also. There you go. And here you select what kind of operation you want to do. So A is for addition, M multiplication, division, subtraction. And I chose multiplication. And this is the crank that you will turn, one turn, to multiply this number by this one. So let's take an easy one. 3, 7, 0, 4, 0, 7. Multiplied by, let's say 9. Okay, so I turn the crank, and look what's happening there. The carriage move. I did one turn, and then I check the numbers. And let's see, 7 and 0. What's the answer here? 6, 3. That works. 4, 3, 6. 7, 3. Yeah, 9 times 7, it's 63. So then you add 6 here. There you go. You have the result of your multiplication directly on the bottom numbers. One turn. I can multiply this number again by 9, if I turn the crank once more. So that was a huge improvement over the existing calculators, because this one can do the multiplication in one turn.
So let's have a quick history of multiplication using mechanical device. I'm going to talk about a few of those here. Of course, this is one of them, the abacus. You can do multiplication with this one. Sure, not easy, but you can. This is another one that I will present later. And this is one of the inventor, Mr. Barber here, that we'll present later also. So if you go down, multiplication, it's just a series of addition. So let's take an example. I take two numbers, 2, 3, 1, 3, multiplied by 4, 5, 6. The first thing you do is 6 times 2, 3, 1, 3. 1 up, 6 times. And then the second thing that you do is 5 times 2, 3, 1, 3. But times 10, sorry. And finally, you do 4 times 2, 3, 1, 3 times 100. So if you count, that's a lot of operations, 6, 5, and 4 operation, 15. So if you use one of these devices here, that's, if you recognize here, that's a Felix arithmometer, you have to turn the crank 15 times. So it's possible, but it's not easy. Now, let's go down to 1972. Mr. Edmund Barber, this guy here, released a patent, and it's a device for direct multiplication. So what's the idea? The idea is that you represent the multiplication table by one way. You look at the multiplication table, you know all the multiplication, like 2 times 2, it's 4. So you have to represent that with a mechanical device. What they did was to use some cylinders here that I'm taking that directly from the patent. And you can see that you recognized on the right, sorry, here, you have the multiplication by 1 or by 9. In fact, this is 9, sorry. On the right, this is 9. So 9 times 1 is 9, 8, 7. Why? Because 9 times 2 is 18. So you have 8 here, and then you have to carry 1. Here it has the opposite. 1, 2, 3, 4, 5, 6, and so on. So this is the idea. You take a device, physical device, and you represent the multiplication table in some way. So he patented that, but there was no practical device made from this patent here. So here's the 1, here's the 2, and so on. Now, a couple of years later, Mr. Ramon Berea was, it's an American guy, but from Italy, had a new patent. It's another device for direct multiplication, and we go back to the same idea. You have to represent the multiplication table in some way. So what he used was one cylinder here, and you can see that there's some holes on this cylinder, and the size of the hole will be the number. And in front of this cylinder, you have this conical pin here, and depending on where the cylinder is, the pin will go more inside the hole, depending on the number. So again, that's another way to represent the multiplication table. And this one also was never really commercialized. It worked. I mean, he made a prototype and it worked, but it was never really a commercial success. They never sold any of those. So you can recognize number 1, number 2. So a couple years later, we have this gentleman, Mr. Pafnutichevichev. Nice beer, by the way. And I almost left this one out of the list because it's a multiplication device, but it's not one operation. It's just a series of addition. However, it's pretty smart and pretty interesting because if you look at this here, it looks like any type of adding machine, except that the wheel on the right here will move, and the second one will move at 1/10 the speed of this one. So if you do one complete turn of this one will do only 1/10 of a turn, but continually. So it's not jumping from one number to the other one. It's always moving in between. That was his idea. And how can you make multiplication with that? Well, you take this additional device here on the right and you program that to make the number of turns that you want. So it's pretty smart. It's kind of a modular device where you have the additioner here on the left and the other one on the right where you can make multiplication. So that's why I almost left it out, but I thought it was interesting to talk about it. Now, a couple of years more, Mr. Léon Bollet, a French guy who worked, his dad was making automobiles, steam engine, in fact, but big ones. And this guy was a mechanical engineer and invented a machine also for multiplication. And it's the same idea as the other guy. He said, we have the multiplication table, so let's try to represent that in some way. And there it is. So this is only one digit here, but you can recognize on the first row here, 1, 2, 3, 4, 5, 6, 7, 9, all the numbers are represented. The second one will be multiplying by 2, so 2, 4, 6, 8, 2, 4, 6, and so on. So you have the multiplication table in only one row here. So the machine was really complicated because you had to carry over for the tens and so on, and it worked, but his problem was that the machine was too expensive, so they couldn't sell too many of those, and it was not a commercial success either. And finally, we arrive in 1895. Mr. Otto STEIGER, a Swiss guy, which said, okay, let's take all of these ideas of multiplication table and make something very practical and use it on something that we can sell. So his way of representing the table was using some plate, and only one here is shown, and this one I think is for the 6. So the first number will be 6 here, and then you have 12. 2 times 6 is 12, so you have a 2. And then 3 times 6 is 18, so you have an 8, and so on. 24, and so on. So you represent on one plate the digits, and on the second plate you represent how many tens you have to add. For example, if you take 6 times 6, will be 36. So you will get a 6 here, and the second plane you will get a 3. So you will move the tens by 3, and you will move this one by 6. So yeah, that was pretty smart also. And the advantage of this one is that it really made a very nice machine, and he sold, I think it's like 40,000 of them, which was very good. Okay, so this is another drawing directly from the patent from Mr. Steiger, and on this one you can recognize on the right the crank moving all the plates, and this is an example for the digit 8. So you can see on like light color, this will be the digit, so 8 times 1 is 8, and on the more dark color here will be the tens. So 8 times 2 will be 6 and 1. 8 times 3 is 4 and 2. So with only one movement, you can multiply all these numbers here by 8. Just push by whatever you need to push, and those will turns the wheel and the tens. So yeah, pretty smart, pretty clever, and I think he made a good success with the commercialization of this.
Okay, now that we talk a little bit about the history of the device, I want to show you a little bit more about the multiplication, because this is what really was the difference between this device and the other ones. So if you remember in the video, I took an example and I said, let's take a number. It's this one, 2, 3, 1, 3, and multiply this number by 456. So the first thing I do, I zero here everything. Okay, and I also move the carriage completely on the right. So I'm ready for my first multiplication. And if you look at the number to multiply, 456, I will start by the 4. So I put this index on 4. Make sure that I am on multiplication. And I'm doing the first turn here. So when I do that, I multiply by 4. And if you notice, the carriage here moved one direction to the left. Now, the next number was 5, 456, so I put 5 here, I change nothing else, and I do another turn. Okay, and finally 456, so I put the 6, and I do a final turn of this crank here, and I'm done. So 2, 3, 1, 3 multiplied by 456. What do we have here? 1, 0, 5, 4, 7, 2, 8. Take your calculator, you'll see this is the correct answer. And you notice only 3 turns for a multiplication by 3 digits. That was really a nice advantage for this machine here. The only problem is, as you can see here, it's a really big machine. It's heavy, and it took completely the size of a desk. And look at my hand next to the box. It's a huge box, but a very nice box. I mean, you have those handles here on the side, which are very easy for moving the box. Oh, by the way, this is a Bulgarian calculator. I'll talk about this one on the next video. Well, another example. Now we're going to talk about subtraction. Because this machine is capable of doing the subtraction directly on top of the addition. The addition is very easy. All you have to do is put the numbers put the multiplicator by 1, and of course you get the numbers here added. The only thing is if you select addition here, this carriage will not move, so every time you add more numbers, they just add it to the other one. Now let's take an example for S, subtraction here. It's a little bit different in the way that you have to set up the number, the first number here. So let's take an easy example. I'll take let's say 223, and I will subtract 24. So 223 minus 24, let me guess, 199. Subtraction here, I go. One turn. What do I have here? 199. Wonderful. So easy. And this is just a very simple example with two numbers. So, but you'll do the same thing for multiplication, addition, division. Division is a little bit more complicated. I don't think it's really easy to do that. I need to study that a little bit more. But let me see if I can open that so we can have a look inside. I didn't open it completely because I don't want really to break anything. Some of those screws are really hard to remove. But anyway, just here you can see the mechanism here for the crank. So when you turn, you can see that the movement is modified to move those drums here. And below that, those drums here are barely visible, but these are the one moving the wheel right here, and the bell. So I read that on the user manual here, that the bell is for division. If you make a mistake, the machine will tell you and ring the bell. Pretty clever. There you have it. So I put it back together. The Millionaire, made by Mr. Hegley. You can see Hans W. Egley here, and I found something very nice. The serial number here is exactly the same as the one inside on the chassis, so this is an original model. Oh, one last detail. You see this? This is a safety pin, so when you ship the machine here, you can put your safety pin right here, and the carriage right here will not move. So that's very nice. I mean, it's a protection for shipping. The other protection being this one. If you look on the box here, this will go right here in this hole and will not move during shipping. So very nice machine, more than 100 years old, and still working perfectly. I love it.